Hi everyone, this is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we are going to see the topic named Basics of Pulse Width Modulation. Introduction to Pulse Width Modulation. Pulse width modulation is a technique to control the power delivered to a load using a digital signal, commonly used in motor speed control, light that is LED brightness adjustment, and communication systems. So what is PWM? Pulse width modulation is varying the width, it's nothing but varying the width of pulses in a signal to encode information or control power. So we can simply say it as a controlling the power by varying the power input signal given to the particular device. A continuous switching between on and off states taken place through this pulse width modulation. The key parameters to consider in pulse width modulation is nothing but duty cycle and frequency. Duty cycle is nothing but percentage of on time in one cycle. In one time cycle, so how much percentage of on time is nothing but the power on time. So remaining time is nothing but the power of time. So based on that on time, the LED brightness or the device working will takes place. For example, for formula for calculating the duty cycle is nothing but on time by total time into 100. So this is nothing but your duty cycle. Coming to the frequency, number of cycles per second in hertz determines the smoothness of the output. So if the frequency is high, the output will be smoother without any unwanted signals. And then types of PWM. Here we are having three types, starting with fixed frequency varying duty cycle and fixed duty cycle varying frequency, and finally advanced technique like phase correct PWM. Then coming to the advantage of PWM, high efficiency in power delivery when compared to the previous methods, any resistor type methods. And then coming to the minimal power loss, and then smooth control over a wide range, and compatibility with digital systems are few other advantages of the PWM. Coming to the applications, motor control varying the speed and torque, and in LED dimming controlling the brightness. Power supply, in power supplies voltage regulation is taken place with the help of the PWM, and communication modulation techniques are best examples. And here is the best example for the duty cycle. So in the above waveform, it is mentioned as duty cycle 70%. That is nothing but positive half of the cycle will be 70%, and the negative half, that is nothing but the switch off state, that is 30%. So during the 70% of the time cycle, the device will be on and the output will be obtained. So this is nothing but the high duty cycle. So if like this input is given to the LED, then it glows brightly. So coming to the next, that is a lower waveform. So that is nothing but low duty cycle, mentioned as dim LED. So this is because of that is only 30% stage of the cycle, time cycle will keeps the power on with the help of this duty cycle, and remaining 70% mentioned as a negative off cycle, so their power will be off. So this is the best example waveforms for the LED example of our pulse width modulation. So how we are changing the brightness of the particular light emitting device. Similarly, for speed controlling everything for DC motors, we will be using the pulse width modulation, which is the best method when compared to the previous methods, any resistor type methods or relay type methods. We are concluding with the PWM as the best method. And summarizing these topics, we have seen still now we have seen about the what is pulse width modulation and what are the main points to consider similar to the duty cycle and to the features. So that is frequency. So these are the two features, duty cycle and the frequency are the two main features. and we have seen the advantages and applications of the pulse width modulation, and we have seen the best example based on the duty cycle, best waveforms based on the duty cycle. So coming to the summary of this pulse width modulation, it is a versatile and efficient controlling technique when compared to the other previous methods, and key aspects are duty cycle and frequency. So duty cycle makes the, that is how much time the device will be on and how much time the device will be off. That part is taken with the help of the duty cycle, and how the output should be there, that is taken care by the frequency parameter, and widely used in electronics and communication systems. So coming to the assessment of this session, which of the following is a key parameter of PWM? So in these given examples, duty cycle is the correct answer. So what happens when the duty cycle of a PWM signal increases? So that is nothing but if LED, the light glows brighter. So if it is any DC motor, the full power will be gone, then it will be running in a better manner. So what does the frequency of a PWM signal determines? This determines the smoothness of the output signal. Okay. So thank you for everyone. We can see in the next video.